So now we're going to look at our 555 integrated circuit timer. And so you might be familiar with this IC, or you might have heard it used because it's a fairly common integrated circuit to use when creating timer circuits. So in this video, we're just going to look at a basic overview of our 555 timer. And then in following videos, we're going to get a more detailed look at sort of what's going on under the hood of this IC. So our 555 timer is something called a monolithic IC. And so basically what that means is that it's all made on the same piece of silicon. So we're going to see later on that it has resistors, op amps, a flip-flop, transistor. All of this is made on the same piece of silicon. And so this 555 timer was actually invented back in the 70s. So actually in 1971. By somebody called Hans Kamen-Zind while he was working at a company called Signetics. And so originally, all of these 555 timers were BJT, but now, so of course it's been around for a while since the early 70s, so now we can find this with MOS and actually CMOS technology as well. And so remember, the advantage of our CMOS technology is that we have a lot lower power consumption compared to BJTs. And just again as a reminder, our CMOS stands for complementary MOS technology, complementary metal oxide semiconductor. So let's look at a couple of the functions that we can achieve with this 555 timer. And so seeing this list, we'll realize why this is such a commonly used IC. So we can use this for precision timing. So maybe we want to generate some type of clock signal. We can use it for pulse generation. We can use it for sequential timing. Time delay generation. We can use it for pulse width modulation. So I'm just going to put PWM, so pulse width modulation. We can use this 555 timer also for something called pulse position modulation. So pulse position modulation, which is often abbreviated just PPM, not to be confused with parts per million. And we can also use this to create linear ramp generation. And so of course this is a lot of different functionalities for this one chip. We're not going to look at all of these, but we're definitely going to take a look at sort of our timing and our pulse generation. So in general, this 555 timer has two operation modes. So operation modes, we can have astable and we can have monostable. And so let me just sort of sketch what each of these waveforms would look like. For astable, that's going to be sort of where we have sort of a fixed square wave going on, and so these should be equal duty cycle, equal frequency, regardless of what's going on. We're not having to put any inputs into it. Our monostable state is saying that we have sort of a preferred state, and then some external excitation occurs which causes it to go to a second state, and this one is not stable. So after a certain amount of time, it'll decay back to our stable state. So that's the difference between our astable and monostable. And so which one of these operation modes we're in depends on external component and external components and how they're connected. So let me just be more general and just say it depends on external connections. And so again, we're going to dive into the details of this astable and monostable a lot more in later videos. So in general, these timing pulses have a relatively wide range. So our timing pulses can range from microseconds, 10 to the minus 6, to on the order of hours. So again, depending on an application, maybe we want something relatively quick. So we could have kilohertz or above frequency, but we could also be measuring instances or counting pulse instances for something that's occurring on the order of hours as well. So a pretty wide range there. Something we're going to see as we dive into those videos about astable and monostable configuration is that we have adjustable duty cycle. And so that's something we'll see also in the lab. We're going to look at one particular configuration in the notes, which has a limited control over the duty cycle. And then in the lab, I'm going to ask you to consider a different, coming up with a different configuration where we have more control over the duty cycle. And then the last general thing we want to point out is that this 555 timer can source or sink up to 200 milliamps. So of course, source or sink means the current is either being drawn from it or sinking, it's going into it, but it can do up to 200 milliamps. And so what this means is if we want to be powering something directly from our 555 timer, like an LED, that's perfectly reasonable. But if we're trying to use our 555 timer to directly control something like a motor, which is going to be drawing larger currents, that's not something we're going to do, and we're going to have some type of amplifier in the circuit as well. So that covers it for our introduction to the 555 timer. In the next video, we're going to look more at what's going on under the hood in this integrated circuit.